All right, welcome back. So we got this little lab going on back here. All right, and just like I said previously, I'm gonna have two different VLANs on one switch and the same two VLANs on the other switch, and they're going to be part of two different networks, and we see how they're going to communicate going across these particular ports right here. So let's go ahead to this switch over here and let's create our VLANs. So let's say there's going to be VLAN 100 and VLAN 101. Obviously, we're going to create them on both switches. All right. So we're going to come here. Let's maximize. Let's go to the CLI. Let's give this switch a name, config T, and we'll call this switch 1. Just keep the thing simple. SW1. Now, let's first take a look at the VLANs that exist by default. Do show VLAN, and you see everything's part of VLAN 1. All the ports are active on VLAN 1. We're attached to ports, I believe, 3 and 4, if I'm not mistaken. Yes, we are, 3 and 4. Okay. So, but they're both different VLANs. So let's go ahead and create the VLANs first. So we're going to go VLAN 100. Wow, you just created a VLAN. Hold on to your pants. Okay. That's just creating a VLAN right there. VLAN 100, you create a VLAN. But you should give your VLAN a name. If you don't give it a name, it's going to assign itself its own name, but it's going to be a number. It's going to be like 00100 or 0100, something like that. You don't want that. We're not computers yet, so we identify things by name. So give VLAN 100 name. Let's call VLAN 100, let's call it name faculty. Boom. And let's create the other one. VLAN 101, enter, name, and let's call this students. All right, so let's exit, like you would in the exam, and do a show VLAN. So now we have two VLANs that we created, but we yet have to assign to any ports. We haven't assigned the VLANs to any ports. Okay, so let's go ahead and go to the other the other switch, and let's do the same thing. All right, because we got both VLANs over there. We got enable, config T, and then we're going to do VLAN 100, name faculty, VLAN 101, name students. UWR, do show VLAN, not, you can do in the test. There they are, faculty students. And let me make sure that it says students on this side as well, not just student. Okay, students as well, and faculty. All right, so we have both VLANs. Now, that's all it is to creating and naming a VLAN. That's all it is. So what we're going to do now is we're going to assign the VLANs to their particular ports. So in this case, VLAN 100 will be assigned to port 3 on switch 1, and VLAN 100 will be assigned to port 3 on switch 2. So, and then 4 on 1, and so forth. Okay, so let's go ahead and do that. So VLAN 100 on port 3. So we got to go config T. We go inside that port, interface F0/3, enter. Now, when you assign VLANs, you must assign them the ports. By default, they're set to dynamic auto. You need to put them as an access port to assign the VLAN. Packet tracer is very forgiving. So you go switch, TCH, port mode, access, and then you tell it switch port access VLAN. This is 100. So now VLAN 100 is assigned to port F03. So I'm just going to up arrow now I'm going to go to the port. I'm going to go to 4. I'm going to hit enter. I'm going to go to switch port mode access, turning the mode of that port as an access port. And then I'm going to go ahead and tell it which VLAN is that going to be a part of, which is VLAN 101. Let's exit. Let's do it the proper way for the exam. Exit. Copy, run, start, enter, enter. Show VLAN. Now you have faculty, which is in port 3, and students, which is in port 4. Awesome. All right, and we're going to do the same thing over here in the other VLAN. Exit. And then we're going to go VLAN 100, name faculty, VLAN 101, name students. No, we just did that. Sorry. I don't know why I'm doing that. Okay, I'm assigning it now. So sorry. Config T interface F0/3. We just created it, so never mind. Int F03. So we go switch TCH port mode access, and then switch port, too many P's, access VLAN 100. Then on all barrel port 4 mode access, and then VLAN 101. Control Z, WR, show VLAN, and now we have the same thing. 100 VLAN on port 3, 101 on port 4. Not that it really matter, I just want to stay consistent. It doesn't matter which port I assigned on the other switch, the faculty one, but just to be the same. So what should happen is that now host 1 should be able to ping host 3 because they're on the same network. This is 100.1. This is 100.2. Let's see. What happens, pray tell? Ping. And you can't see that because I'm in your way. Let's bring that over here. Ping 192.168.100.2. Oh, that's right. The first timeout is because we are going through an Ethernet network. Request timeout. Uh-oh. What's going on? It's not able to ping across. What's the problem? Let's try the other one. Let's try VLAN 101. And again, let's bring it this way so you guys can see. Ping 192.168.101.2. And again, the first timeout, I always say because it's Ethernet, but it looks like it's going to continue to time out. Let's let it go through. Let's see what happens. What is the problem? Must be the IP addressing, right? I have my IP addressing wrong? No, the IP addressing is correct. I'm pretty sure. It is 101. I was pinging 102, 101.2. So it's not that. See, this is the problem. And this looks like a very similar example that you may run into in your examination. The only VLAN that can go across, because ports 1 and 2 that you see here, ports 1 and 2, those are access ports, but they should be trunk ports. From switch to switch or switch to router, those ports should be trunked when dealing with VLANs. Only the native VLAN is allowed to go across access ports or trunk ports. So let's prove that theory. Let's go ahead and grab a PC, one on this side. Let's put one on this side over here. I'm just going to connect it to any random port. Let's pick port 20 here, just to be completely different than everybody else. All right. And then let's use an easy IP address. Let's just use 1.1.1.1. Yes, I know that's a public IP address. Well, this will be 2, obviously. And then, yeah, we'll leave it at the default. Forget about the gateway. We're not worried about the gateway anyway. This is just to prove a point. All right, and this will be 1.1.1.1, default mask. 1.1.1.1, default mask. So everything's green. That's awesome. And let's see if we can ping those. Ping 1.1.1.2. And we can. Why is that? Because that particular port 20, and let me go ahead and go inside switch 2. It'll be the same thing on switch 1. Control C. I'm going to do a show VLAN. Well, port 20, ladies and gentlemen, is part of VLAN 1. So VLAN 1 at this point is the native VLAN, the admin VLAN, the management VLAN, the admin VLAN, whatever you want to call it. That native VLAN is the only one allowed to go across access ports or trunk ports, because in the header of the native VLAN, there's something called a PVID, a personal VLAN identifier, that when they see it coming across, hey, that's the native VLAN, let it through, let it through, let it through. But every other VLAN, 2, right? 2, all the way to 1001, must go across trunk ports. Must go across trunk ports, which means that you need to trunk your ports. Let's say I'll come over here and do it on this one, switch 1. All right, just to, and I'm gonna do a range command and start getting used to this. Int range F0/1-2. Simple enough. Now you're in config if range. So whatever you do now is going to take effect in those 2 particular ports. And you can go switch port mode trunk. Okay. And if you were to do now show in trunk, now you see that F01 and F02, the trunking mode is on. 802.1Q encapsulation is on for those ports. And if you come over here, you see how it's changing. It's changing. Something just happened. Spantry is going, hello, what's going on here? So Spantry did its thing. Not really, Spantry didn't do anything. It's actually that it's changing modes from dynamic auto to now a trunking port. And if you look at these ports over here, do a control C, do the same command, showing trunk, you see that automatically these ports down here got trunked as well. You don't have to go down there and manually trunk those ports. Once you trunk them on one side, since they're connected together, it's going to go ahead and trunk the ones on the other switch. So based on the theory, now VLAN or host 1 on VLAN 100 should be able to ping 100.2. Now it can, because it's going across a trunk port. So that's important to remember. Let's test the other one. 101.2, and now you get a reply. So that lets you know right there, because you will see a very similar scenario, okay, on your examination, where you're going to have one particular VLAN that's able to go back and forth without an issue, but the others cannot go across without the issue, or cannot go across because they have an issue. What is that problem? The problem is that the ports going from switch to switch are not trunked, because again, the only VLAN that can go across an access port is the native VLANs. all other VLANs must go across trunk ports. And the reason that is because those other VLANs get tagged. That's where the phrase tagged VLANs and untagged VLANs. When they talk about untagged VLANs, we're talking about VLAN 1s. When we're talking about tagged VLANs, we're talking about everything else. Because tagged VLANs are the ones that have to go across those trunk ports. So that's very, very important to know. So that's it. That's all there's to creating a VLAN, assigning a VLAN, well, creating the VLAN, giving the VLAN a name, assigning the VLAN to a port, and then making sure that if you're going from switch to switch, that those ports that are going from switch to switch are trunked, so all the VLANs other than the native VLAN can also go across those ports. All right, simple as that. Not a problem. I will see you in the next lesson.